Greetings, math fans. All right, so this is day 10, and we're going to talk about position, velocity, and acceleration. All right, and if you guys remember when we took derivatives, right, a derivative is rate of change, okay? And so if I said, what is the rate of change of position, we're talking about rate of change being the change in position over change in time. And so change in position over change in time, think about it. If I do miles over hours, it's miles per hour, which is velocity. Okay, so that is change in position, which is basically the first derivative. So that's what we have here. This guy right here is position, s of t. Velocity is the first derivative, s prime of t, which again is change in position. Speed, math fans, is almost the same thing as velocity, except it's the absolute value of velocity. Okay, so in other words, if you're in a car and you're going forward, your velocity is positive, your speed's positive. If I put it in reverse, and I go backwards, my velocity is negative, so I'm going negative 5 miles per hour, but my speed is still positive. I'm still going 5 miles per hour, but it just happens to be in a backwards direction. Okay, so speed is always positive. And then think about it, if I do change in velocity over time, that's like saying meters per second, which is meters per second squared. And if you remember any of this from physics, you've taken physics, but it's meters per second squared, is acceleration. And so that's exactly what it is. I have a of t, the acceleration is the first derivative of velocity or the second derivative of the position. Okay, so it's change in velocity. And this is also important here too. Average velocity, okay, is change in position over change in time. Now let me tell you the most common mistake that people make, math fans, is they ask for the average velocity. Let's say you're given the positions and you're given the velocity and you're given the time. What people like to do is they like to do velocity. So v of t1 minus v of t0 over t1 minus t0. They love to do that, but this is wrong. So please don't do this, because this is actually saying velocity over time, which is really acceleration. Okay, so when you're doing average velocity, make sure you use the position on top. Position over time. Very important. Okay, so don't forget that. All right, so let's go to a couple examples here using this knowledge. All right, and as we're going through this, just because we can't fit all this on the screen, just look at you know what you're looking at. Okay, you got all your different equations and everything. All right, a cougar moves along a line, so its position in feet at any time t is greater than or equal to 0 is given by the function s of t is equal to t squared minus 5t minus 4. Find the displacement during the first 10 seconds. So what you need to do, math fans, is you need to say s of 10 seconds minus s of 0 seconds. Okay, you plug in 10, you plug in 0. Let me tell you another common mistake, math fans. Another common mistake is that people forget the s of 0. They're like, oh, during the first 10 seconds, and they just do s of 10, and that's it. They don't subtract s of 0. But you have to realize that just because we're at 0 seconds doesn't mean we're at 0. The position's at 0. In fact, well, let's do this, and you can see s of 10. If I plug that in, it's 46, and minus an s of 0. Well, just look at it. If I put a 0 in there, don't I get negative 4? So truly, at 0 seconds, I'm at negative 4 as my position. So it's minus a negative 4. So my answer for this one is 50 feet. And don't forget your units. Okay? But that is a common mistake, is for people to leave that baby out right there, and don't do that. All right, find the average velocity during the first 10 seconds. Okay, so again, this is going to be position s of 10 minus s of 0 over 10 minus 0. So we're going to get 46 minus a negative 4 over 10 minus 0, or 10, right? So we get 50 over 10, which is 5 feet per second. Again, don't forget your units. Okay, so that's average velocity. Find instantaneous, that's the derivative. So we're going to say v of t equals s prime of t, and I take the first derivative, I get 2t minus 5. And then, of course, I do s prime of 6, put a 6 into that equation, so 2 times 6 minus 5 gives me 7 feet per second. Okay, not bad. Find the acceleration when t is equal to 6 seconds. Okay, well, we're just we're finding a of t, which is the first derivative of, or the derivative of v of t, right? Which is just right? And it's also the same thing as s double prime of t. Okay? And so that's pretty easy. So my answer for this prime, so it's s double prime of 6 is equal to 2 feet per second squared. Okay, that's your units, don't forget. Now this is the deal, math fans. What if I said, hey, what is the acceleration at t is equal to, let's double it, 12 seconds. Well, you should recognize that it's going to be 2 again, right? It's going to equal 12 feet per second squared. Oh, I wrote 12. It looks like 12. It's 2 feet. That's a 2. Okay, it's equal to 2 feet per second squared. So the deal is, it's constant. It doesn't matter what the time is. It could be 10 times equal to 1.2 billion seconds. It's still 2 feet per second squared. All right? What does it mean when the particle changes direction? Well, think about that. When it's traveling forward, and I'm not talking about changing direction as in going side to side or making a right turn, left turn. I'm talking about going from forward to reverse. Okay, so what does it mean when it changes direction? It means that the velocity equals 0. That's changing directions. Okay, and at what time does the particle change direction? Well, you set the velocity, which is 2t minus 5. You set that equal to 0. So we got 2t equals 5. So t is equal to 2.5 seconds. Okay, that's when it changes. That's when it goes from going one direction to reverse, or reverse to forward. Okay. All right. So let's move on to the next page here. You're given a position graph, and I ask you to find the velocity. Remember what the velocity graph is. Isn't the velocity the slope of the position graph? Okay, so what you're going to do is you got to find the slopes at different points here. So let me write down the slopes here first, and then we can fill it in the velocity graph. All right. So the slope for this guy here from 0 to 1 degree, it's down 1 over 1. So it's in the slope. I'm going to put it in red here. So this is going to be a slope of -1. And then, of course, the slope here from 1 to 3, the slope is 0. And the slope from 3 to 4, it's up 2 over 1, so the slope is 2. And then from 4 to 6, the slope is down 1 over 2, so it's -1/2. And then the slope is up 1 right here. And then the slope is down 2 over 1, or -2. All right, so let's fill that in. Okay, you have that all in front of you. And from 0 to 1, the slope is -1. We're going to put open circles because we don't really know what's going on. Oops, it's got a kind of a thick line there. Okay, and then it's from 0 to 3. It's going to be, slope is 0. It's my velocity. And then from 3 to 4, it's going to be 2. Okay, and then from 4 to 6, it's going to be -1/2. And from 6 to 7, it's going to be 1. And then from 7 to 8, it's going to be -2. Okay, pretty easy, right? No problem. Okay, let's go to our next graph now. Speed graph. Again, I can't fit both of them on here. But remember, the speed graph is the absolute value of the velocity graph. So basically, like from 0 to 1, it was -1. Well, now it's +1. That's pretty easy. It's right here. Okay, 0, 0. That doesn't matter. So 0 to 3. Sorry, 1 to 3 is 0. And then from 3 to 4, that's still +2. Okay, and then from 4 to 6, it's going to be +1/2. And from 6 to 7, that was +1. And then from 7 to 8 was -2. Well, now it is +2. Okay, that's your graph. That's your speed graph. That's pretty easy. All right, let's move on here. Okay, given this velocity graph, I got a lot of questions that you need to answer. All right, so let's do that. It says at what. So I'm gonna keep this graph here. You guys have your notes in front of you, and we can fill the things in. At what value of t is the particle motionless? Where is it at rest? Remember, math fans, this is a velocity graph. So at this point here, at actually that value, and at this point here, that's where it's at rest, right? That's where the velocity is 0. So that's why it's going to be. Let me fill this in now. It's going to be at 1/2 from 4 to 5, and we'll say union, and 7.5. Okay, so that's pretty easy. The next one, when is the object moving forward? You need to understand the object is moving forward when the velocity is positive, just like our slope graph, right? Remember that? When we're up here, the slope is it's positive. We talked about that. The slope is positive up here, and the slope graph is negative here. So when you have a positive velocity, that means you're moving forward. So where is it moving forward? It's moving forward from 0, from here, 0 to 1/2, and from 5 to 7.5, where it's positive, right? So does that make sense? So now here's the deal also. This guy right here, this 0, that is a bracket. Now why does that have a bracket and this guy down here have a parenthesis? Why is that true? Well, at that 0, I don't really know what's going on right at that 0. In fact, at 0, it's neither moving forward or back. So I do really know what's going on. It's stopped. That's why it has a parenthesis. But you need to understand, at 1, it is a positive velocity. Okay, even if it is a corner, it's still a positive velocity. So that's why it's a bracket over there. So let's fill that in. It's moving forward at 0 to 1/2, union 5 to 7.5. Okay. All right, let's keep going. When is the object moving backwards? Well, that's when it's negative. So it's negative right in this area here and in this area right here. Right. So from 1/2 to 4 and 7.5 to 8. So 1/2 to 4, union 7.5 to 8. And again, this is a bracket because look at 8, right? Isn't 8 down here? Right? So we're going, it's negative at that value. Even if it's a corner, the velocity is still negative at that point. All right, so let me get rid of all this red now so I can make other comments here. All right, so let's go on to the next one here. When is the object's acceleration 0? So let's think about that. When is the object's acceleration 0? What is acceleration? Isn't acceleration a of t equal the first derivative of velocity or the derivative of velocity? So remember, that means acceleration is the slope of the velocity graph. So let's look at the velocity graph, and it says when the acceleration is 0, that's when the slope is what? Okay, it's when it's okay. So when is the slope in the slope at when it's 0, or when the acceleration is 0? That means the slope is 0. So you guys agree that the slope is 0 right here, the slope is 0 right here, and the slope is 0 right here? So that's your answer. And now think about it. Is it bracket or parenthesis? It's a parenthesis because again, we're talking about what's going on right at that corner there. I don't really know. Okay, I don't know if it's a 0 slope or is it a positive slope. I really don't know, or a negative slope. I don't know what's going on. So that's why it's parenthesis. So let me fill that in. Object's acceleration is 0 from 1 to 3, union 4 to 5, union 6 to 7. Okay, when is the object acceleration positive? Well, that's when you have a positive slope. Where is it a positive slope? Right here and right there. So from 3 to 4 and 5 to 6. So 3 to 4, union 5 to 6. Again with parentheses. When is the object acceleration negative? Well, when you have a negative slope, which is right here and right here. Right? And it's a negative slope. So from 0 to 1 and 7 to 8. So 0 to 1, union 7 to 8. Okay? What is a particle's acceleration at 5.5 seconds? Well, isn't 5.5 seconds right at this point here? And you can even kind of look at the average velocity if you'd like, but it's right on this. It's right on the line there, right? So what is the basically right? We're looking for the slope. I'm asking you what's the object's acceleration. So what is the slope at that point? Well, the slope is 2 meters per second, right? Because it's up 2 over 1. So it's 2 meters per second here, right? Or you could just find the slope, right? You could just say 2 minus 0, y over x, right? 2 minus 0 over 6 minus 5, which gives you 2 over 1, which is 2. And it's positive 2, okay? So that's it. Let's put that in there. 2 meters per second squared, of course, right? It's acceleration. All right, now this is the tricky part. So I'm going to get rid of this red stuff again on top here. Okay, so the question is, when is the object slowing down? When is the object slowing down? So let's write this. I'm going to write this out here. When is it slowing down? Now that's a good question. You look at the graph and you're saying, well, gee, it's slowing down, isn't it, when it's decelerating, right? When it's decelerating. So think about it. If I look at this, let's look at a couple parts here. First of all, let's look at this guy right here. Isn't the acceleration decreasing here? Okay, well, up to this point, so up to this point right here, isn't it slowing down? I say it's slowing down here. And what's going on over here? Isn't it actually accelerating in a negative direction, though? Because think about this. This is a velocity graph, math fans. So isn't that 0 at rest? So if I'm going for the first half a second, I'm going from 1 meter per second to 0 meters per second, I'm hitting the brakes on a car. And then what happens when I'm going from 1/2 second to negative, or to 1 second? I'm going to negative my velocity. I'm going to negative 1 meter per second, right? So basically what I'm doing is I'm going in reverse. I'm accelerating negative. I'm going in this case, reverse. So I'm actually speeding up. Okay, it's a little hard to understand that, but if my velocity is going more negative, I'm speeding up. As I'm approaching 0, I'm slowing down. As I'm going away from 0, I'm speeding up. That's a good way to look at it. So basically, I'm slowing down from 0 to 1/2. And where else am I slowing down? Okay, well, what is this? Let's look at this guy right here. Do you agree that I'm going negative 1 meter per second here? And then as I go from 3 seconds to 4 seconds, I'm slowing down in a negative direction. So an example with a car, right? I'm going in reverse at negative 1 meter per second, and now I'm hitting the brake until I get to 0. So I'm also slowing down from 3 to 4. What's going on here? I'm accelerating. I'm speeding up. Okay, so here, this is a little confusing here, right? This guy right here that was speeding up. This guy here is slowing down. You label it clearly here. Slowing down. That guy's speeding up, going up like that. Well, what's this part right here? Okay, again, I'm going at 2 meters per second. I'm hitting the brakes. So at 7 seconds, I'm starting to hit the brakes until I get to 7.5 seconds, which I'm stopped again. So I'm slowing down here. Right? And then what's going on here? I'm hitting the accelerator, but I'm in reverse. So I'm speeding up again here. Okay, so I got everything labeled here. I hope you guys understand what it means now. People don't think of a negative acceleration as I'm always slowing down. I'm slowing down if I'm going in a positive direction or positive velocity, and its acceleration is negative. Yeah, I'm slowing down. But once I cross that threshold of the velocity being 0, I'm starting to slow down, or I'm starting to speed up again in the reverse direction. Okay, so let's go and fill in our numbers here with all that information there. When is it slowing down? It's slowing down. I need a little room here. So between 0 and 1/2, union 3 and 4, union 7, and 7.5. That's what I'm slowing down. And when am I speeding up? Speeding up between 1/2 and 1, union 5 and 6, union 7.5, and 8. Okay, so that's when I'm speeding up. All right, let's move on to the next page. This is my position graph, and some pretty basic questions here. But remember, if it's like going from 0 to 1 second, I'm going from position 1 to 2. All right, so then when I'm going from 1 second to 2 seconds, I'm going from position, I'm actually going backwards, aren't I? I'm at, like, if you think of it as miles, right? I'm starting out at 1 mile, and then I'm going to 2 miles, and then I'm going back to 0 miles, and then I'm going to -1 miles, and I'm staying at -1 miles. I'm going up from -1 miles to 1 mile. So I'm moving to two miles ahead. Then I'm steady, and then I go back to 2 miles. So in other words, I'm going back and forth, right? So let's answer a couple questions here with that. The first question is, at what value of t is the particle motionless? So when is it at rest? All right, well, it's at rest right here and right here, right? It's not moving. It's at, like this bottom one, it's at -1 mile. And the top one is at +1 mile. So let's fill it in. Between 3 and 4, it's motionless. Union 5 and 6. Okay. When is the object moving forward? Well, it's moving forward here, right? Because it's going from 1 mile to 2 miles. And it's positive here. It's going from -1 mile to 1 mile. And it's positive here. It's going from 1 mile to 2 miles. So think about it. When is the object moving forward? Isn't that the same thing as when the velocity is positive? Okay, and what is the slope of the position graph? The slope is velocity. So that's my answer. Between 0 and 1, between 4 and 5, and 6 and 7. So it's right in here, 0 and 1, union 4 and 5, union 6 and 7. Okay, and of course, going back to here, when's it moving backwards? Well, it's moving backwards when the slope is negative, when the velocity is negative. And so between 1 and 3, even though it's got this little point right here, it's still a negative slope at these points, right? So between 1 and 3 and 7 and 8. Okay, so between 1 and 3, union 7 and 8. That's when it's moving backwards. All right. Anyway, that's it, math fans. That's basically just talking about position, velocity, and acceleration, and looking at a lot of graphs, and coming up with information based on all those graphs. That's it. Have an awesome day, math fans. Adios. Goodbye.